Warm welcome from IDA Telangana chapter. This session is part of our Poshan Mah events, and we could do a couple of events during this month in terms of involving and increasing awareness. We've run a Facebook campaign, like many of you all, on posting your kitchen garden and encouraging the terrace garden concept. It was wonderful to see each and every one of you really already doing so much of terrace gardening or the little kitchen gardening, and it was great to see all those posts. Dr. Anandan here is here, and he himself has a huge terrace garden which he shared with us very recently. We also did a recipe contest as part of the events, and we did a quiz competition which was very unique because it was live. We had about 200 participants, and it had a wonderful scoring system which kept changing based on the fastest finger and the correct answer. So that was another unique experience that we had. Today, I welcome all of you for this webinar that we are conducting. We had started off thinking that probably it is very much for IDA Telangana chapter, but I realized that a lot of you have joined from all over India. So henceforth, I think we should keep capacities to much higher. We I didn't expect this kind of a response. So a very warm welcome to all of you from IDA Telangana chapter. This session, particularly today, is something long awaited, and I would hand over the reins to our moderator, Dr. Malleshwari. She is working as a chief dietitian with Global Hospitals, and is been in the practice for about 25 years, I think, because Malleshwari has been in the field much longer than what I have been. I myself have been there for about 2 decades now. She specializes in gastrointestinal nutrition. They have a huge bariatric wing, and she's somebody who's very keen on doing every case presentation or a presentation that she does in great detail. She's also our RD coordinator for IDA Telangana chapter, and we've been able to structurize the entire RD recognition and planning of the examination through her. Over to you, Malleshwari.
Thank you, Harita. Good afternoon, all of you. I think this is a long-awaited session. We've always discussed with Dr. Anandan. He's a part of the IDA Telangana chapter. We've always discussed with him about this FCT table. The book is really huge and we cannot carry this book through. So we always used to tell him earlier it was very easy for us to carry this book, but these days it's very difficult. But anyway, moving along, I'm sure as I was reading through the introduction of the FCT tables, I understood that this has come into conception from 1937, and it has moved a way long with the latest publication which has come out in 2017, and day in and day out, whether it is nutrition research or whether it is the students in the college or we in the hospitals have been using these tables through. Yes, and over the period of time from 1937, there have been inclusions of new foods, new components, new nutrients, and this change has come up with the following up of the nutrition, the disease in the community. And at the same time, we've come a long way through. Apart from just the nutrients, I think as India has got a lot of different types of cuisines and variety of foods produced in different parts of the country, we even have one more step ahead as to the names of the foods have been given in different languages. So there are 11 languages mentioned in our nutritive value book. Without taking too much of time, I would like to introduce the speaker for today. We have two speakers today. I'm introducing the first speaker, or the first session is Food Composition Tables, Reference and Significance. Anandan sir, can we have your first slide, sir, so that we have the CV? Before I read on, as I read on, if the CV is there, I think it's going to be more better.
Can I share my screen?
Yes, sir, please. Dr. Ananthan has been an active participant in the IDA Telangana chapter, and he's the secretary of the IDA Telangana chapter. He is the scientist D at just a minute. I think sir is sharing his screen.
Is it okay? Because my first slide is there.
So I think he doesn't have the CV there, Malleshwari. You go ahead and introduce him.
Yeah. So I am happy to introduce to you Dr. Ananthan. He's the scientist D at NIN ICMR Hyderabad. He has a PhD in biochemistry. He has over 19 years of experience. Presently, his main work area is the FCT analysis. He's also involved in the development and standardization of analytical methods to quantify various nutrients, also has worked in quantifying bioactive phytonutrients and measuring their free radical scavenging capacity in functional foods. He's also working on a few projects where there is a study going on the biodiversity and food systems in the population with regards to the food availability, accessibility, and consumption patterns. He has about a lot of research papers to his credit, and he has authored 3 chapters. He is also on the faculty or the research supervisor for the PG as well as the PhD students. He is a member of IDA and NSI. He's a coordinator of the SAP Foods Regional Center, FAO Consultants for Food Consumption Development, and consultant by FSSAI NetFab. So over to you, Ananthan sir.
Thank you, madam.
Ananthan sir, your video please as you talk.
My slide is visible to everyone?
Full screen. Yes, sir. You can start.
Sir.
Thank you very much for a nice introduction, and good afternoon to one and all. Of course, as Haritha ma'am was telling, actually we supposed to organize this on behalf of our nutrition month. Unfortunately, it's got delayed, long delayed. But anyway, in continuation of this our celebration, and we proposed in the first week of October. I'm going to talk today the overview of food composition tables and its significance. Since I worked from the beginning for the development of Indian food composition tables, I wanted to elaborate a lot of clarifications and how the method, so many areas, how we involved all those things we are going to touch in different topics. Like I will start with the overview of the food composition tables in global level, different national level, and then we will touch upon the special emphasis on the Indian food composition tables 2017. In that particularly, there are main important aspects what we have carried out specifically for the identification of key foods, and then national level sampling, different analytical methods, what we have used, how we develop, and the quality assurance and quality control programs, what we have adopted. And then finally, what are the other significance in the for the usage of IFC 2017, and what are the food composition tables users. And there are few limitations across the use of the food composition tables, what are the things, and then finally I will conclude it. Let me start with the quote by McCann and Widdowson. A knowledge of the chemical composition of the food is the first essential in the dietary treatment of the disease or quantitative study of the human nutrition. So with this, let me have one or two brief introduction slides. What is food composition tables? So food composition tables is nothing but it's a repository for the content of nutritionally relevant chemical constituents, which is available in all the foods consumed by human as well as the animal. Particularly the food composition tables, it's relied upon the nutrition research as well as the health practice, since it provides a critical information for the content and the distribution of various these nutrients in different foods. In order to construct, develop, and manage of any food composition table, so there are different critical stages involved. Particularly, initially the designing, statistical designing, then food sampling, characterization of the components, analytical methods, development of analytical methods, estimation of the nutrients, and data quality assessment. Finally, we have to document and publish it. There are different varieties of food composition data available. If you take the original analytical value, which is nothing but either you can take it from the published literature or unpublished laboratory report, and this report exclusively if they prepared for the compilation of any food composition database. The imputed value, it can be derived from the other analytical value, it should be the similar. For example, the peas can be derived from the beans, the dried value can be derived from fresh value, defatted value can be derived from fresh value. So similarly, calculated value, it can be calculated from the recipes or the ingredients by using the yield and the retention factors. The borrowed value, it can be borrowed directly from the other databases, but with the sufficient reference for the original sources from where we have taken. Presumed value in some situations, because of the rules and regulations of anybody, so then certain values will be directly will be assumed, or it can be considered as a zero as well. If you look at international level, there are many internationally used databases available. You might be seeing the ILSI. There are FAO database, many FAO databases are there. Initially, this FAO database created, first compiled in 1988, and then subsequently for every new publications, they used to update it. There are so many databases maintained by this InFoods FAO people. And in that particularly this dietary database version 2, composition database for biodiversity, analytical food composition database, and tables for the West African composition tables. Similarly, you can see in other countries like Canada, they have 2 databases. Caribbeans, they have the database. Even USDA, they have USA, they are having 4 database. Essentially, the first one, USDA database, the primary and the preliminary database widely used. Apart from that, Alaska Traditional Knowledge and Atwater Woods also, they are having the database. In European country, almost most of the European countries, they are having their respective database food composition tables. You can see the Belgium, Danish. I had a chance to visit this Danish food composition table where they developed. This is Denmark Technology University. I happened to meet some of the people. Then the German, Greek, Ireland, Italy, Dutch, Spanish, Czech, everyone, most of these European people also, they are having their own country database. Coming to the Asia, most of the Asian countries, particularly you can take Bangladesh, China, and ultimately we have the US, our Indian food composition tables. Now the Pakistan also, they are coming up. Now we are working for Sri Lankan food composition table, and now we are planning to take up the Maldives, and then Mauritius also, they are planning to develop their food composition tables. So these are all the different country database for their particular food composition tables. Coming to the particularly for our Indian food composition tables, NIN is responsible. Generally, it started way back in 1937 by when the NIN was originated in Kunnur. That time only they started by including 208 foods with only 14 nutrients. They published as a nutritive value of Indian foods and the planning for the satisfactory diets. And with that origin, then subsequently they revised in 1951 by increasing another 1990 foods more with some more nutrients. It was revised with the same name, nutritive value of Indian foods and the planning of satisfactory diet. And then when our father of nutrition research in India, Dr. Gopalan, he revised this book as Nutritive Value of Indian Foods in the year of 1971 by increasing the more number of foods as well as the nutrients. And then subsequently in 1989, there again a lot of nutrients and the foods added and they revised the same book. After I think after 1989 there was no revision on this the food composition of our Indian foods. Then later on in 2017 we published the latest Indian food composition table with 550 key foods with more than 200 individual nutrients or chemical components. So this is what I'm going to emphasize, how we planned, how to collect the sample, how we collected the sample, how we analyzed the sample, how ultimately we brought out this Indian food composition tables, which it may be useful for everyone. And I think I can expect many questions from all the audience, because already I used to hear from our IDA members, there are many people, they are having a lot of doubts, which is the reason like I wanted to emphasize particularly on the IFCT, and I also ready to clarify all your doubts. This is the flow chart, how we developed our IFCT. So starting from the identification of key foods and the sample framing. Once the identification of key foods and the frames, the sampling was done, then the foods were collected. While collecting the foods, we used to identify the nomenclature, including the common name and the binomials, and simultaneously we have documented using all electronic documentations. And then later on, we used to composite the sample. Then we analyze the nutrients. While analyzing the nutrients, we used to use quality controls, both in-house quality controls as well as external quality controls. So these are all the things I'm going to explain in details in subsequent slides. Then after analysis, the analyzed data were reviewed thoroughly. Then it was published both in the soft copy as well as in the hard copy. The first stage is identification of key foods. As you know that our Indian cuisine varies widely across the country as per the region, culture and traditional, and all this characterized by different both plant foods as well as animal food sources. Analyzing all the foods which are consumed by the entire country, it is a little difficult due to various reasons, including the prohibitive cost involved. So therefore, we have to come to the conclusion, or we have to decide which is essential and that needs to be prioritized for the composition analysis. So we adopted this USDA method. It's called the key foods approach, and already it's well defined. The key food is defined as the foods which contribute up to 75% of the nutrient intake by the population. So how these contributions will come to know? This method, the key food approach method, combines the food consumption data along with the nutrient composition. Then getting the input, we will be ranking and we will identify which foods are key foods as per the the ascending order. So this kind of the food consumption data generally we will get by the National Dietary Surveys only. Fortunately, we are having the Nutritional Monitoring Bureau, NNMB, which is our one of the NIN's department or division or the bureau which was functioning. They were collecting the dietary intake almost 10 different states, which covers 3/4 of the geographical area and 2/3 of the total population of country. So we used this NNMB 2006 rural survey, which involved 30,244 individuals in all the age groups, collected using this 24 hours dietary recall method. Based on this, we identified the key foods. Then after identifying the key foods, then we have to design the sample sampling. The sampling also with the reference to Pearson, they used in Thailand. The sampling procedure to generate the National Food Composition database is a key foods involved selecting self-weighing nationally representative samples to estimate the composition of foods. So this was done to the sample. It was decided to sample at the district level, and whatever the samples collected at the district levels, it was analyzed as a key foods. Since all the states of our country or the union territories, it's not in the uniform size of in the population. So because the number of districts in each states and the union territories, it varies. So ultimately we decided to go for the district wise sample collection. So again, the country was divided into 6 geographic regions because it varies. India is having a lot of the environmental vegetations, soil in terms of the soil, in terms of the variety. So considering all these agro-climatical, agriculture practice, the varietal basis. So we divided into 6 parts: north, south, east, west, center, and northeast. And then the same kind of the classification or the division also used by the NFHS various surveys, not only the recent surveys, even the previous surveys also they used to use, except the Uttar Pradesh. Here in our study, Uttar Pradesh we have included in the central region instead of northern region. So this covers starting from Kashmir to Kanyakumari, even the west side to east side, everything we covered. So you can see different states in different zones, central, east, north. I will explain you in detail. Then coming to the next, after identifying the districts or the states, again we have to identify, coming to the exact number of districts which needs to be collected, which needs to be identified for the sample collection. Each states, it has number of variant number of districts. So we decided the frequency distribution of the number of districts. We were arranged in the ascending order like this, you can see here. So based on the number of districts, so we decided how many number of districts needs to be selected from each states. So these are all the number of states which contains within this range of districts, like 1 to 4 districts, there are 9 states, 6 to 10 districts, there are 4 states, like that. So based on this, so we decided the number of the districts which needs to be selected from these kind of the states. So accordingly, we derive this many number of the districts which needs to be identified or which needs to be undergo for the sample collection. So this is the north zone, which covers from Kashmir. This is the south zone, and wherever the red spots are there, that is identified districts for the sample collection. And this is the east zone, west zone, center, and northeast. So which covers 107 sample collection spots are the districts, which you can see in each states, and the number of districts, and among those things, how many districts selected. Here in the northeast part, because of the size of the state was very less, except Arunachal and Assam, we chosen only as the complete state as considered as single sampling spot. So including the districts and the union territories, we have chosen 107 districts. The sample collection centers. So here I just wanted to emphasize, in each zone, north, east, south, west, center, and northeast, that is called as regional compositing zones. So each zone, there is a center we identified for North Delhi, East Kolkata, South Bangalore, West Mumbai, Central Varanasi, and Northeast is Guwahati. So these composite samples are the composite center we made as a center where we used to bring the samples and composite all the sampling spots or the districts which we identified in the respective region. So out of 630 districts, as I told, 107 districts were identified, which covers 17% of the country. And due to the logistic reasons, the district headquarters was identified as the primary sample, and the towns were identified as a secondary sampling units. Here, so from Hyderabad, after identifying all these things from Hyderabad, so for this project, I just wanted to tell you more than 95 staff we recruited and we were working for the project. Apart from 95 staff, our permanent staff and even from administrative side also, there are few people, they came voluntarily for this sample collection. So we distributed, like we dispersed from Hyderabad to all the sample collection centers or the respective districts where we have chosen to sample collect. We dispersed and then we reached in the respective place. After reaching there, then we collected the sample. Before going to the sample collection, we used to make list of samples to be collected in each trip. Then the local name, the photograph of the particular food which needs to be collected. So everything was given in the small kit, and with that the people used to go and reach the respective sample collection center. After collecting the sample collection center, the samples, they used to come to the respective zones, which is a compositing zones, as I told you, Delhi, Kolkata, Mumbai, Guwahati, and Bangalore. So from here, whatever the samples which collected from the each respective zones, that was homogenated or the composited in this respective zone. Now, all the 107 samples, it was made into 6 aliquates or 6 composite samples. All these samples again we brought back to Hyderabad for the analysis. So now literally we analyzed the samples individually from each composite zones, north, south, east, west, and central, northeast. Then the mean of the sample, mean of this data, we have given as a national wide data in our database. For example, here you can see there are 6 as explained, the 6 zones. If you look at the central zone, there are 4 states, Madhya Pradesh, Uttar Pradesh, Uttaranchal, and Chhattisgarh. Here in the Madhya Pradesh, out of the number of districts, 50 districts, we chosen 8 districts. Similarly, more than 70, it's supposed to be 4 districts needs to be selected. So here also Uttar Pradesh also 8 districts we chosen. Similarly, Uttarakhand 3 and Chhattisgarh 3. So that 8 plus 8 plus 3, 3, we brought to the Varanasi, where the central homogenized or the composite center. Here we mixed it together and we have taken the 2 aliquate from this composite sample that was shipped to NIN for the analysis. So we collected various food samples, plant food samples, animal food samples, and interestingly in the animal foods, we also collected different body parts of the birds, like thigh, breast, wing, liver, gizzard, and even the poultries. The meat sample also we collected in a different parts. Coming to the meat sample, we collected, instead of collecting this 107 sample spots or the districts which identified, because of logistic reasons, we could not collect from the respective place. Instead of that, we collected in the respective composite center itself. Again, In the composite center, we made it into 6 parts. The city, we made it into 6 parts, and we collected all the samples, including the different meat cuts, different body parts. We collected from all the 6 sample places. Again, we made into we composite the samples. From there, we have taken the liquid. All these samples, the animal foods or the fish or shellfish or inland fish, all these samples we have cleaned thoroughly. We removed all bones, and just as edible or about to cook, that stage we frozen into using the dry ice, and that was shipped without changing the cold chain till it reached NIN for the analysis. The fish samples we collected only from respective, directly we went to the fish landing ports, not from the districts which identified for the plant foods. The fish landing ports was referred by CMFRI, Central Marine Fish Research Institute, Cochin, which covers both west and east coast of all fish landing sites. In the west, Mumbai, Goa, and Kochi was selected, and here the Vizag, Chennai, and Mandapam was selected. So these are the 6 different landing sites from where we have collected all the sea fish and shellfish. And here also we cleaned, evacuated, and removed all the bones, deboned, and finally we packed in the dry ice and we shipped into Hyderabad. Then after receiving, this is, we have collected the sample, we have composited the sample, we have transported the sample to Hyderabad. Excuse me, just give me 1 minute. Sorry. As soon as the sample reached NIN, Food Chemistry Department, for the analysis, so we used to check the samples, the integrity of the samples, whether it is damaged, whether it is acceptable condition. If it is any damage or all this, particularly the green leafy vegetables, we have to throw it. If it is not acceptable condition, we used to throw it. Then immediately that particular sample we used to enter into the next sampling collection cycle. So we used to collect in the next cycle. All the foods were properly recorded using alphanumeric code, and this food code was used throughout the analysis till the book, till the database was released. Then once the sample was unopened, the package was opened, and the sample preparations again, if it is the green leaf vegetables, we used to use a liquid nitrogen for grinding the samples, or the meat samples we used to use a homogenator, or if it is a dry sample we used to use the domestic mixie or the flour mill. After grinding the samples or the powdered the samples, we used to store in a airtight container with appropriate location with the proper labeling, which was used till 6 to 7 years. In case of any repetitions or the cross checks, everything, it was properly used. These are all the few pictures where we used to composite the samples at the sampling sites, and then we brought the samples through air with the proper package. You can see this is a fish samples we transported from different seaports with the thermocol box inside the dry ice. Even the permission, we have to get a lot of permission in the airlines, because only the fish is not allowed in the air. I don't know, whatever the reason, except the fish, everything it can be transported. The fish was very difficult to transport, but we got the special permission from the ministry. So we're using that, we transported. Once it comes to the laboratory, yes, all our staffs we used to clean and then remove the edible parts and then we have to grind the samples. We used to store the samples. Then coming to the analysis, the analytical parameters which we used to use, that is very important, equally how we used to do the sampling, because that method is very, very important for accurate results or the reliable results. So we used most of the parameters wherever the AOAC methods are there, efficient analytical chemist method. If it is available, we have used. I'm going to show you all the parameters, what are the different methods we have used it. And if the method is not there, AOAC method is not there, then we have used the suitable, appropriate, internationally published method, and that we have chosen, and we have validated, standardized. Sometimes we used to develop by mixing the 3-4 methods, and we used to develop the new methods, and all standardized and developed methods in our laboratory was duly validated using the IUPAC or AOAC norms. All the validation protocols, you have to see that your linearity, your reproducibility, your recovery, robustness, all those things, LOD, LOQ, everything you have to do in order to, validate your method, and that was documented. So then for the new components, because of increasing demand in order to understand the phytochemical or phytonutritional importance of all the commonly consumed foods, so we have included a lot of bioactive components in our new food composition database, which including all these bioactive components, there are about 300 food constituents were studied, were quantified. You can see different parameters in the proximates, water-soluble vitamins, fat-soluble vitamins, individual free sugars, oligosaccharides, sterols, phytopolyphenols, and other bioactive phyto components. All those things we have given in our IFCT book. These methods, whatever these methods, what we have used, it was scrutinized thoroughly for their robustness in analyzing all the components, and particularly before starting these, the foods which we collected all over India, we collected within the Hyderabad and Secunderabad different food matrices, different food groups, because we have to ensure the method which is working for all types of foods, the tubers or leafy vegetables or the fruits, because these different fruits, different foods are having different matrices. So in order to ensure the robustness on these different foods, so we used to collect the samples, and then we have analyzed, we have standardized in such a way that it should work for all types of foods. These are all the methods which we used. This is approximate composition. Mostly you can see AOAC methods, and then only the energy was converted using Atwater conversion factors. And these are all the vitamins, water soluble vitamin and fat soluble vitamins. And vitamin B1, B2, B3, we use the microbiological assay as reported in AOAC, whereas other vitamins, we use sophisticated equipments, very sensitive equipments, reverse phase HPLC or UPLC or UHPLC we used. And similarly for fat soluble vitamins also, the HPLC techniques was used for the quantification of different vitamins. Here, I also would like to emphasize some of the vitamins, the vitamin B6 and the vitamin B9 and even vitamin E, all these vitamins we used to analyze. We have analyzed up to the vitamin level. When we use the HPLC, we can able to quantify the fraction level. In case of vitamin B9, if you take, so we have reported as a total folate, but we have quantified individually all individual vitamins, folate vitamins, tetrahydrofolates, methyl tetrahydrofolates, formyl tetrahydrofolates. So all these 6 different folate vitamins we quantified, and the sum of them we have given as a total folate. Similarly, B6 also, individual B6 vitamins, PL, PM, PM, all those things we have quantified. The vitamin C also we quantified, vitamin C ascorbic and dehydroascorbic acid. So like that, since we have used sophisticated methods and we also standardized the method in order to quantify the nutrients up to their vitamin level. Similarly, the free sugars we have done using HPLC refractive index detector by AOAC method. The starch we have given individual starch, oligosaccharides we use the HPLC method again. The phosphorus we used to quantify by calorimetry instead of AAS, atomic absorption. And heavy metals and trace elements we use the ICP-MS, which is very sensitive. We used to quantify in the ppb level. All other minerals we have used atomic absorption spectrometry either by flame or graphite, or with the hydrate generator also we have used for few metals like mercury, arsenic, all those things. Then the organic acids, oxalates, these were quantified using HPLC methods. The fatty acid profile. So we have very good standardized method which able to quantify 37 fatty acid in the single stretch. We use the fast gas chromatography to quantify all these individual fatty acids. And then amino acids, very interestingly, we have dedicated amino acid analyzer which is able to quantify all 18 primary amino acids. And dedicatedly we used for amino acid analysis. The phytosterols, we use the gas chromatography like that. The polyphenol for HPLC, then phytate, again we use the ion exchange spectrophotometry. Then so total saponin also by the calorimetry method we quantified. So these are all the different methods used for different analysis, and everything was documented. All the methods were validated, and after thoroughly identifying the method, after thoroughly validating the methods we used for the quantification of all the nutrients which reported in the IFCT 2017. The very important scheme, very important assignment while doing this analysis particularly, we have to have the quality assurance and the quality control samples in order to ensure your sample or your analysis is perfect, or your analysis, whatever the data you are getting out of your analysis is correct. In order to ensure the analysis, we use the quality control samples, particularly from the external quality control samples till the method was developed perfectly, or the standardization was done completely. We used certified reference method from European Commission. And again, the standard reference material we purchased from the NIST, National Institute of Standard Technology, USA. So both the CRMs and the SRMs, which contains most of the analytical data, which already we have the reported. Those samples we have used for the cross-checking the quality assurance and quality control. Since these CRMs and SRMs are very expensive, and we may not use for for daily or day-to-day analysis. For that purpose, we have developed our in-house quality control materials, particularly rice, market rice, which we purchased in the bulk quantity, and that was used as in-house quality control. And that in-house quality control is well established through our the regular analysis. And then ultimately, once the in-house quality control is established, that was used batch to batch analysis. And similarly, the CRM and SRM also was used in the every alternative days or weekly once. Apart from this, our laboratory, food chemistry laboratory, we are participating regularly in the external proficiency testing programs, the PT programs like WAPOL, PT programs. And similar to that, one or two programs we used to participate. Even the WHO PT programs also we are participating for fatty acid analysis now, ring trials. So these are all the different food groups which we have reported. In each food groups, you can see the number of the food samples what we have collected. which is coming around 542 foods, which includes different varieties as well. This is the analytical data how we have derived. So this data I have taken from the whole wheat. So when we collected the whole wheat from the respective place, the respective collection centers, which I explained, it's 107 places. When we analyzed each zones, the composite zones individually, you can see the variation from, the 3, 2, 4, 5 also. When we analyze the samples which collected from the individual districts or the collection centers, you can able to see the variation is very high. And then the mean of the particular, all the samples, it is 4.2. Similarly, the Western India, North India, other South India, Central and Northeast India also you can able to see. But when we composite the sample, when we composite the sample as I told in the, the sampling plan or the sample collection, when we composite that all East India samples or the West India, North similarly, and you can see that the variation was very less and the mean it was also, it is the SD also, it will come down automatically. So this is the one particular example. I just wanted to explain how the variation will come down when we do the composite samples. Similarly, you can see in the zinc also, when we do the individual analysis, when we do the analysis in the individual samples, yes, of course, the variations will be there. And then coming to the composite samples, the variation will come down. So these are all the different parameters which we have listed in our food composition tables. Table 1 to 12, the fatty acid profile of edible oils and fats is the last table. This is one example what I wanted to explain how the IFCP tables looks like this. This is the one particular example page. Here you can see this is a food code. What I used to say, that's an alphanumerical code. A, you can see in this table, A is, A belongs to cereals, B grains, legumes, C green leaf vegetables. Similarly, it goes to S, T for oils and fats. So those alpha along with the numeric number which represent the number of foods. So this is a food code and the name of the foods which includes the binomial names. And this is the region which how many regions contribute or from how many regions we have collected the sample. And here this is the data which represent the mean and SD. And so the SD of 6 regions, 6 composite centers value. And similarly, this is called in-foods tag names. And these tag names used for the international exchange of the data. I'm happy to say that FAO refers our food composition tables for many countries, and they used to use as a referral. I'm happy to inform that I'm also I'm a consultant for the FAO. I'm happy to see somebody from Ethiopia. Dr. Sarna is here. I'm a consultant for your country as well. And in order to exchange this kind of data, and we used to use these in-foods tag names. And for the easy identification for the page track, I have given this, the label this, the vertical side or the portrait side in order to identify the tables easily. And if you look at the tables, we have given in different Indian languages. Initially, we wanted to give all the 15 languages which is available in our rupees note. And apart from that, there are some other languages like Manipuri, Khasi, like Northeastern languages also we have included up to what we can able to get it. We tried to give in the respective the scripts, but unfortunately the scripts we unable to get for all the foods. Hope I can able to include in the future, the editions. Finally, it was released in January 2017, 18th January 2017 by that Honorable Health Minister JP Nadda ji, and that is, during the releasing time, as Malleswari Garu was explaining in the beginning, the volume of the book, the weight of the book is approximately 1.8 kg. So of course, the carrying the heavy book is little difficult. Even our the health minister also narrated the book weight is little more. So better you please convert it into other digital form, including the mobile app. So based on his the suggestions or the idea, we developed mobile app as well, so which can be used by all the participants. I can show you some of the screenshots, and not only the compositional data, and even there are many more applications are there where you can make use of it. Coming to the users, there are many users apart from our nutritionist or the other scientists. There are many other users are there, particularly the agricultural scientists. They use it for various applications. Then the food technologists, they use it. Dentists nowadays, they use it. All the many physicians, they use it. Even the journalist, I had a call from one journalist from Delhi, and then she was inquiring all those things because of this. She was, the linking the corona lockdown period in terms of the nutrients, what the people they used to, they supposed to eat. So like this, if you look at it, there are so many variety of people, they used to refer the food composition tables. This is what I just was explaining you. So we developed our, based on the IFCT data, we have developed mobile app, which can be freely downloaded from both the platforms, the Google Play Store as well as iOS platform. You please download this mobile app. You can check. So these are all the informations you can get. So what is your nutrient requirement based on your BMI and what is there in your food? So search for the nutrients with respect to particular foods, and you can arrange in ascending order, descending orders. So many options are there to get your data output, and you may get little, the slow because of some reason, technical reason, which we are planning to increase the speed. That will be done in a few weeks time. But anyway, now you can able to download and use it for your application. I also happy to inform you that based on our revised or the recent IFCT 2017, we have revised our RDA, and we also have incorporated EAR, estimated average requirements. That was recently, very recently, last week only it was launched or released by the current Honorable Health Minister Harshvardhan ji. Apart from this, we also have developed our website. This is not yet launched. Just for information, I just wanted to give the glimpse, and which includes different food search for the user-friendly food search. You can search by food groups, content, and QR codes and graphical representations. You can see the QR codes. It can be print, or you can view it and magnify it. You just scan this one, then you will get all the nutrient information pertaining to that particular food. You can see, and even this is by the food groups. If you select the food groups, you can see all the foods, and you can able to see by each foods the respective nutrients. You can also choose the individual nutrients which you wanted to compose, or you can view it. So those things also it's going to come. This is under again the validation. We have circulated among the international reputed people for their suggestions that will be released, and we are also planning to include even the diet survey calculations as well. Will be including for the application of for the many students, because I used to have the calls from many students. They are getting the softwares or the packages, paid packages of softwares. So I'm sure in future we are going to stop all these paid softwares and packages, and we are going to make it free for all the our Indian nationals. There are limitations for the food composition database. The first thing we have to understand what exactly the data, how it is derived, how the data it is either for the the composite sample or the single sample. or how the sampling was done, all those things we need to understand very clearly. So another thing is, so all these food samples are the biological materials. Obviously, the variations will be there among these biological samples. So that also we have to keep it in mind. There are certain variations will be there for these biological samples. Then another thing is, there are some the studies, particularly the metabolic studies, this kind of the where we used to intervention studies. So these diets or the meals needs to be quantified directly instead of calculating from the food composition tables in order to they interpret it exactly. And another thing is, we cannot predict very accurate results for certain nutrients, particularly like very sensitive nutrients like vitamin C and folates. As I told, we have quantified using the folate vitamins and the vitamin C vitamins. So sometimes, the variations will be there. That is the reason we have done the composite samples, that variations can be, the variation can be minimized or the error can be minimized. And sometimes the manufacturer formula may vary when it comes to the laboratory. So that needs to be taken care. So some of the limitations always will be there that can be overcome. Then finally, I'll come to the conclusion. In this Indian food composition tables, as I explained, the important factors, the key foods identification we have done, and the national level food sampling we have identified. That in order to improve the composition database for the national level food composition database. And then we have arranged adequate infrastructure. Here, I'm happy to say that all the food components, almost more than 200 food components, what I have explained, it can be done, it can be quantified under the single roof. This kind of facility you cannot see anywhere else. So such kind of facility, even the equipments, the dedicated equipments for dedicated nutrients, the dedicated personnel, technical personnel, we allotted the technical person, we will use one system and one parameters. So all these kind of precautionary measurements and the well-equipped equipments, and then the infrastructures we develop in order to develop this in IFCT in, this thing. And the identification of the key foods, and then the sample design, analytical parameters, what I have explained, all those things, it's we have included in this one. Altogether, it is called as an ideal plan. And this ideal plan made to analyze more than 115 analytical parameters. We have analyzed, though we have analyzed individual the sampling sites, all the 6 regional composite sites. Ultimately, as I told, we have given as a mean of 6 regions. In case for any research purpose, if any regional database, if it is required, then they can approach us, and if they justify proper reasons, we are very happy to provide them the regional database. Thank you so much, and I wish to acknowledge it. ICMR, our council.
The host has asked you to start your video. Yes, okay, fine.
Contributed the entire fund for the study, and our research team, this is the last batch of our research team who work dedicatedly day and night sometimes, and even the Saturdays also they work for the development of IFCT. Thank you so much.
Thank you so much, Ananthan sir, for giving us the activities which happened, which ultimately culminated to the formation of the IFCT tables over the years. Sir,